Especially with regard to analyses, when we've completed the experiment and we have the data in hand, there are certain things that happen. And there's a great example given in a Nature article where they talk about the Texas Sharpshooter approach, in the sense that what you do is you study the data so long and so hard that you actually start seeing patterns where there aren't really patterns within the data. And that leads to the concept of just so storytelling, that after you have seen it, that you start crafting a story that fits what you're observing. And then there's also the idea of sometimes you're myopic in your approach to it. You're so convinced that your model is correct or your hypothesis is correct that you're not asking yourselves, are there other explanations that may do a better job of explaining the variability in the data? Or is there another statistical model that may explain the variability within the data? And the last one, which is one I have the most experience with in my career, is actually asymmetric attention, where you actually come in and when you're doing the analyses, if you achieve statistical significance, you're more ready to accept that, and you stop digging and you stop looking at different possible explanations. Whereas if you have something that's non-significant, then you start digging and pressing much harder, and you're asking yourself, well, why were my expectations not met? Should I try a different model? Should I look and see if there are more influential points or outliers, to see possibly is there an explanation for why I did not observe what I wanted to see. The way you avoid those is very simplistic in a lot of ways, and these are the strategies that we like to employ. First we want to sit down and really write out the approach to begin with. Be as clear as you can. This is actually a reviewable criteria. It's been there in NIH for years, where you provide a detailed analysis approach, a strategy. How are you going to go about going through the data, and what models are you going to build? How are you going to check the assumptions? What is your strategy to find outliers? And if outliers are there, how are you going to do a sensitivity analysis with regard to those outliers, instead of potentially removing them from the data set? What are the comprehensive strategies? Reaching out to either a colleague, or even better yet, reaching out to an expert in the field that is actually approaching the same scientific problem but from a different paradigm. Let them see the data. Let them be able to say, if I was analyzing this data, or if I had this data in hand, this is the way I would interpret it. And that way to actually understand, is there a different or possibly a better explanation of what you're observing? My favorite one of all of them is the blinded analysis, especially from a statistician's standpoint, to be able to hand a data set that has removed instead of revealing this is drug A and this is placebo, just label them A and B. That way no one's biased in trying to believe which way the p-value should go, or which way what the statistics should look like, and just say, can you tell me if there's a difference between the two groups? And allowing them to do the analysis completely independent of you, to see if they're coming to the same conclusion about the assumptions, to see if they're coming to the same conclusions about which test is best to apply. See if they're identifying the same outliers as you. And therefore, a blinded data set approach is actually one of my favorites. The final one is what we call devil's advocacy, and that is where we come in and literally just say, what is another model that could work, and say, is that superior?